Hi there guys, in this video we're going to have a look at the volume and surface area of cylinders. Now on the screen you'll see lots of different cylinders in the world. We've got scuba tanks up here at the top right, lipsticks, hydraulic pumps of the cylinders. I think that's tea, it could be candles, I think it's tea. Pringles, the worst flavours ever but cool colours. At the top we've got like a tank, a heating tank, and you can see the pipes of cylinders, and my personal favourite, a gin distillery, where they make all my favourite gins. Cylinders everywhere, so it's really important we understand how to make them and how to maximise areas, etc. In fact, that's not what we're doing at all, we're just working out volumes and surface areas. So, there's a few things you need to know. You need to know the area of a circle. I'm just going to write A of a circle. And that's pi r squared. You need to know that. You need to know the circumference of a circle. I didn't mean to write that. Let's just get rid of that. So of a circle. Now, most of you would call it pi d. There's a catchy song on YouTube, the Circle song. I think it's the Circle song 1 and 2, which are exactly the same. It's very confusing. So pi d is a good formula for circumference. Or what you can use is 2 pi r. And the reason you can do that is 2 r's is equal to the diameter. 2 radii added together is the diameter. Now, I'm going to use this one today purely because the formulas just flow nicer, and I'll explain that in a little bit more. But first of all, what you need to appreciate is these are prisms, and before I go any further, let's actually have a look at what we mean by a prism. So what is a prism? So here are 2 prisms. The one on the left is a cylinder, a circular prism, and the one on the right is a cuboid, a rectangular prism. You could have triangular prisms, like a Bartolomeo, for example. You can have trapezium prisms. I hope I said that right. Maybe trapezoid prisms. But basically a prism, if you look at the cylinder, you've got that circle at the top, and it goes all the way through, like so. And that means it is a prism because it has this, what we call a cross-sectional area all the way through. So no matter where we cut it, it will be there. The same can be said with the rectangle. And I've just taken the right-hand side, but I could have taken the top, I could have taken the front. They're all different rectangles, but you'll see that that cross-section is repeated all the way through. So basically it doesn't taper to a point like a cone would. A cone is not a prism because that circle going up would get smaller and smaller and smaller, or going down would get bigger and bigger and bigger. So that is what we mean by a prism. Now, the volume for all prisms are exactly the same. It's the area of the cross-section times the length of the prism. And you can see the length I've put here in purple, and these lines are in purple. So this is what we mean by the length. So if here's the cross-sectional area, how many of those fit in? If this is the cross-sectional area, how many of those would fit in? Okay, that's what we mean by a length of a prism. So that's great. So, you know, that one formula ticks all the different types of prisms. But now what we've got to do is look at the cylinder in a little bit more detail. So let's just go back to here. Right. So we already know that one, but then there's another problem, which is the total surface area. Now, for us to really understand this, what we've got to do is unpeel the cylinder. So if you take it all apart, what you actually end up with is 2 flat circles and a curved, basically, well, it's a rectangle, but when we curl it up, it becomes a curved surface area. So that's what they sometimes do. They say total surface area, which is the 2 circles plus the rectangle. Or they might just say the curved surface area, and that is this rectangle here. Right, okay, well this should be pretty easy now, because a circle is pi r squared. So if we've got 2 circles, it's 2 pi r squared. But the rectangle, you could put in here length times width. But that's pretty hard, because we don't have the length and the width given to you ever. Okay, but how, I'm just going to try and draw along this line as best I can. That's not bad. How long is that? Well, hopefully you can see that that line there is actually exactly the same distance as that. We've just unpeeled it. So to find out this length, this is going to be the same as the circumference of the circle. So I'm going to say 2 pi r. Now, just change colour here to orange. Well, this length here, if you think this is the bit wrapped around the circle, this is the height of the cylinder. Could call it length. Most people call it height when it's standing up this way. So what we end up with is this formula, 2 pi r squared plus 2 pi r h. Now, you'll see I use 2 pi r. I could use pi dh, but 2 pi r squared plus pi dh doesn't flow very nicely. 2 pi r squared plus 2 pi r h, it flows much better. So that's the one I'm going to use. And in fact, in your exam booklet, when you actually come to do your GCSEs, whenever they are, they're going to tell you the curved surface area of a cylinder. They won't tell you the total surface area, you have to add this bit on, but they are always going to give that to you. But why not just learn it? Much easier. So they're the two formulas you need to know. Volume and total surface area. So let's have a little bit of a practice. So let's start off with the volume of this one. Okay, so I'm always going to write volume, but that's the area times the length. That's for all prisms. The area for this one, the cross-sectional area, is pi r squared, and we're going to times it by the length. So here's my formula. So I could have called that height as well. That would have been absolutely fine. So we've got pi times 25, 5 squared, I just did it a bit quickly, times 8. Okay, that's easy, isn't it? That's 200. So the volume is 200 pi centimeters cubed. That's in terms of pi. Obviously, I could use a calculator. I'm not a massive fan of doing that. Total surface area. Write the formula. It's 2 pi r squared plus 2 pi r h. So we've got 2 times pi times 5 squared. I did it this time instead of writing 25. Plus 2 times pi times 5. And now the height, so this is the height, this is the radius, so times 8. So we have 25 times 2, 50 pi, plus 10 times 8, 80 pi, so we have a total of 130 pi centimeters squared. Area 2 dimension, volume 3 dimensions. As simple as that. Let's have a look at another one. So this is a reverse problem. So let's see how far we go with this. So the volume, so they're telling us the volume. So we know the volume of any cylinder or any prism is the area of the cross section times the length. I'm just going to call it height for this one, just because I feel like it. So I could work out the area. That's not going to be too much of a problem, but I'm going to just write pi r squared times h, or pi r squared h. I could lose the times if I want to. So that's my full formula ready to go. But I don't know the height, but I do know the volume. So whatever they give you, just substitute that in. Pi is just a number. We've got the radius, that's 4. Don't accidentally put 8 in there. Very sneaky. And we've got h. So we can just rearrange this to find out what h is. I'm going to just tidy this up. I wouldn't normally do this. I might just do that in one step. But that's 16 pi times h is equal to 600. So h is 600 divided by 16 pi. That's in terms of pi. I could type it in a calculator, round it to 3 significant figures, for example. And we could even ask you to find the total surface area now, which is absolutely fine because we've got all the information we need. Just bung it in your calculator, bung it into the formula. This is way better. So let's just look at the volume of this one. Okay, so the volume, now what they probably need to do is tell us a little bit more information. So let's assume that this is a right angle here. Looks a little bit more likely. So if the volume normally is area times length, which is pi r squared times the length, well, now it's basically a quarter. So we just divide it by 4. So it's going to be pi times 5 squared, because 5 is the radius of the whole cylinder, yeah, times the length, which is 20. 25 times 20 is 500, so we have 500 pi centimeters. Oh, I didn't divide it by 4, did I? Well, Wally. Let's just pop that divided by 4. 500 divided by 4 is 125 pi centimeters cubed. Now let's do the total surface area. This is going to be a little bit harder. Okay, so I'm just going to look at the curved surface first. Okay, so let's just look at the curved. So the curved surface area is 2 pi RH, but we've only got a quarter of that now. So we've got 2 times pi times 5 times the height, which is 20, and we're going to divide all of that by 4. Okay, I'm going to do 20 divided by 4 is 5, 25, 50. So this is 50 pi centimeters squared. Now let's work out this bit, which if I combine it with here, I have half a circle. So let's call this one 1, let's call these 2. So we've got half a circle, so pi r squared divided by 2. So that's equal to pi times 5 squared over 2. I could have worked out a quarter of a circle and then times it by 2, but what's the point in that? So we've got 25 pi over 2, or 12.5 pi, let's do that, 12.5 pi centimeters squared. Okay, now we also have this and this, which they're also going to be the same because it's a cylinder, and this is going to be 5 times 20 because they're rectangles. So we've got, let's call these 3. So that's just length times width, yeah, for the area of a rectangle, which is 5 times 20, but we have 2 of them. So 10 times 20 is 200 pi. So what do we actually have? We have 250, 262.5 pi centimeters squared. So you can see it gets much harder if we start chopping it up, but you know, they're pretty simple formulas, just you have to take your time and work them out. Okay, hopefully that's made perfect sense. Best of luck everyone, and enjoy it.